let's work with this kinematic equation right here. This one is one of the longest ones that I know a lot of people sometimes struggle with. But first thing first, let's go into our first step, which is what are we finding? So the question already asks us how far has it traveled after 6 seconds. And fact that it says how far means we're either using distance or displacement. So for now, what I would recommend is D or XF equals question mark. Now let's read it so that we can pull our important details that are going to support us. The Volkswagen Beetle moves at an initial velocity of 12 meters per second. It coasts up a hill with a constant acceleration of negative 1.6 meters per second squared. How far has it traveled after 6 seconds? Okay, so we're going to go ahead and begin to pull our important details. We know that the initial velocity is 12. Initial, like your name, means the starting of something or the first or the beginning. So that means VO equals 12 in this case. It's coasting up a hill, but then the acceleration is a negative. So it's probably struggling a little bit. So that means acceleration equals negative 1.6. There is time in this problem, so T equals 6 seconds. So far, that's kind of all we have in this problem. So let's see which equation can help us with this, right? So we have final velocity, final position, starting velocity, acceleration, and time. It's not going to be the first equation because, again, acceleration is there and it's not here. The second one is not going to be it because there's position in this problem, and this equation doesn't give us position. Now this gives us acceleration, but it doesn't give us any time, so it's not going to be that. This is for average velocity, and there's no positioning here in this equation. Now let's get to this one. This has the final. Now we don't have starting, but we can kind of guesstimate because there's a final, there must be a starting somewhere, right? This has starting velocity, which we have, time, which we have, acceleration, which we have, and time, which we have. This seems to make the most sense, but before we choose that, let's go through the other two. This equation asks us to find displacement, average velocity, by using an average velocity and time. Acceleration is not part of this equation, so it's going to be hard to apply. And with the final kinematic, to find change in displacement, we need to subtract final and starting. And again, there's more to our equation and our details than that. So this second kinematic equation makes the most sense. So we're going to apply that. In this case, we can establish that starting velocity is 0 because we can say it starts from an origin. Whatever that origin is, it's a 0 for us right now. And we're trying to figure out from 0 to what position is it now. So 0 plus 12 times 6 plus 1/2 negative 1.6 6 squared. Because our equation is XF equals XO plus VO times T plus 1/2 AT squared. Now I can simplify. Like we said in the past, the 0 can go. So now we have this and this being multiplied and then added together. This times this gives you 72. 6 squared is 36. 6 squared is 36 multiplied by negative 1.6, and that gives you negative 7.6. Divide that by 2 because you're taking half of it, and that gives you negative 28.8. So here we have negative 28.8. Add them together, and you should have received 43.2. So the answer is 43.2 meters.